this is my video submission for my first exam for math for something. So now we're tackling question 1, and question 1 is specifically part A, where we have 30 pieces of candies, 29, well it was like 29 chocolate and 1 licorice, but here we have 29 Hershey Kisses and 1 Reese's Cup. Now for the point of this one is speaking for the question, I hate Reese's Cups, and I do not want the Reese's Cups. So we're working with 30, but in reality we're working with 29 because I do not want to get the Reese's Cup. So on my first turn, I will take 5, leaving us with 24. Now, no matter what, since we have 24, no matter what my opponent takes, I will match it to make it an equal number 6 combined, because 6 goes into 24 4 times. So this will go around between us. It will be 4 rounds, and then by the end of it, I will take in the rest of them, and my opponent will have taken the Reese's Cup. For example, say my opponent takes 3 on the first go. I take 3, and that makes 6. He takes 2. I take 4. He takes 1. I take another 5, like the beginning. And now he's left with 6 Reese's Cups. I mean, not Hershey Kisses. So no matter what, I'm going to get away without getting the Reese's Cup. So let's say he takes 5 on the last go, and I take 1, and that forces him to take the Reese's Cup. So no matter what, on the first turn, you have to take 5, and then from then on, you have to match for 6s. So if he takes 3, you take 3. If he takes 2, you take 4, and et cetera, et cetera. So you do not have to take the Reese's Cup. So now we're on to part B, and in this scenario, I do in fact like Reese's Cups. I like them in real life as well. So in this situation, we're not working with 29 like before, hypothetically, because I took this out. We're working with the full 30. Our method still applies. We're still trying to match our opponent for 6, because 6 goes into 35 times. The only difference this time is you're going to let your opponent go first, because you're always going to be matching them, and you will always have the final turn. So, for example, let's say my opponent starts out and they take, let's say 5, like last time. So then I take 1. They take 2. I take 4. They take 3. I take 3. They take 2. I take 4. The most they can take is 5. And as we can see, there are 5 Hershey Kisses leading up to the Reese's Cup. This will always apply. So no matter what they pick, whether it be 5, 4, 3, 2, or 1, I will always have my chance at the final Reese's Cup. Let's say they take 1, and then I finish it off. In this method, no matter what, as long as you match for 6 and give them the first turn, you will always come back with the candy of your choice. So for question 2, it was asked to tell what the difference between a place value system and an additive system is, and then which civilizations' counting systems went where. So first, let's go over the definitions. A place value system is a system in which the position of the digit in a number determines its value, while an additive system is a system in which the number represented by a particular set of numerals is simply the sum of the values of those numerals. So what does that mean? So to put it in Lamos terms, a place value system uses the same grouping of symbols, but their placement in the numeral matters. So like in our system, the Hindu-Arabic system, a 3 in the 1 place represents 3, like 1, 2, 3. But a 3 in the tens place represents 30, like 3, 1, 10, 2, 10, 3, 10, 30 altogether. And then a 3 in the hundreds place represents 3 100s. 100, 100, 100 equals 300. While in the Roman system, they have symbols for larger numbers. Like no matter where in the numeral an M is, that M is always going to represent a singular thousand. So that's why, like when a number you see like, I don't know, 2,475, you see 2 M's that represent 1,000 and 1,000, and then they add together to make 2,000, and then a bunch of symbols after that they all come together. So in a place value system, a number changes its value depending where the number is. In an additive system, that value of that symbol never changes, but all the symbols in that are added together. So for our place value systems, we have Hindu-Arabic, which is our own, which we use a place value system. Babylonian, because in the Babylonian system, they do multiplies by 60 and then 3,600. So like a 41 in the second section will not be the same as a 41 in the first section. They'll represent different things. And then Mayan, you have the vertical separation where the dots and the lines, like one dot in a line in the second level does not represent the same thing as a dot in a line in the first level. And in our additive systems, we have Aztecs and Roman. Aztec use a plethora of symbols like leaves, flags, diamonds, and dots, but they all have their own value and they never change their placement. And the Roman are the same way, but they just use numerals like the M's, the C, the D, the L. They all have their value, but that value never changes depending on the movement. So now we are on question 3. Question 3 told us that we had to write the number 2,475, which is in the Hindu-Arabic numeration, into 4 other numerations, that being the Roman, the Aztec, the Babylonian, and the Mayan. So first, we will start with Roman. In the Roman numeral system, it's an additive system. So we all the numerals are lead to the singular sum. So in the Roman numeral system, they have a symbol that represents a single thousand, and you represent each thousand. So that's why we have, and that symbol is the M. So we have 2 M's here to represent our 2,000. In the Roman numeral system, they also, instead of having 4 symbols represent 400, they have one combination of 2 symbols represent 400, and that is to take away. So when a lowered symbol is behind a higher symbol, it's taking away. So we know this C of 100 is taking away 100 from this 500. So we know this altogether is 400. So right now we have 1,000, 1,400. So that leads us, so we have 2,400. Next we have to talk about the 75. So now they have, in the Roman numeral system, they have a symbol that represents 50, but they only have 150, but then they have also tens. The L represents the 50 and the X's represent the tens. This leads us to our 70, and the singular V represents our 5. So the number itself is 1,000, 1,450, 10, 10, 5, or 2,475. Next, we have the Aztec. Now the Aztecs have the what I like to call the leaf system, where each partial end of a leaf represents 100. So 1/4 of a leaf is 100, 1/2 of the leaf is 200, 3/4 of a full leaf is 300, and a full leaf is 400. So we know, so if we divide 2,475 by 400, we'll get 6 and a remainder. But we know that we have that whole 6. So we know we will have 6 full leaves. And 6 full leaves of each 400 represents 2,400. So now all we have left to do is the 75. And so in the Aztec system, they have numbers that represent 10 and 20. So we know that 20 goes into 75 3 times the remainder. So that's why we have our 3 flags, each representing 20. So 20, 20, 20 is 60. That leaves us with 15. There's the symbol for the 10, which is the diamond here. And then we have for our 5, we have our 5 dots. So we have 400, 400, 400, 400, 400, 400, which equals 2,400. We have our 3 flags here that each represent 20, which accumulates to 60. We have our diamond that represents 10. And then we have our 5 dots. So 2,400 plus 60 plus 10 plus 5 equals 2,475. So now we move on to the Babylonian. Babylonian have separation that relates to multiplication as well. So this is our separation. So over here, whatever we have here will be multiplied by 60. So if you take 2,475 and you divide it by 60, you will have 41 and a remainder. So now we have to represent 41. So to do so, in the Babylonian system, they use these little arrow things to represent 10. So we know we have 41, so we're going to need 4 arrows. And the arrows connect in the Babylonian system. So we have our first arrow, our second and third arrow, and our 4th arrow. So now we have 41, and then we need a singular representation, which is our line with a triangle on top. That is our 41. And since it is separated, we multiply it by 60. 41 times 60 equals 2,460. So if you minus 2,460 from 2,475, we have 15 left. So that means in the singular option, we need to represent 15. As we talked about before, the tens placed in the Babylonian system is represented by the sideways triangle or an arrow. So now we know we need the arrow to represent 10, and we need the symbol for 5. So that'd be 5 upside down triangles with 2 lines at the bottom. So this is our 5. So we have 41 times 60, which equals 2,460, and our own 15. So 2,460 plus 15 equals 2,475. Finally, and probably the most confusing, is the Mayan system. So now we know our number is 2,475, and if you know the Mayan system, they have levels based on how high the number goes. And so our number falls between the level of 360 and 7,199. That means we will have 3 levels to our answer. And so in our highest tier, singular dots represent 360 and lines represent 1800. So we have 1 line and 1 dot. So this is 1800 plus 360, or 2160. And then in our second row, dots, so we have dots represent 20 and singular lines represent 100. So we have 3 singular lines. That equals 100, 100, 100. That means we have 300 in our second row. And on the bottom, we have our dots represent 1 and our big lines represent 5. And we have 3 lines. That equals 15. So we have 2,160 plus 300 plus 15, which come to 2,475. So for question 4, we were asked to multiply 27 times 54 using the Egyptian doubling method. So in this method, we start off by doubling the numbers in the left column until we can't double anymore without going over the first number. So we have 1 doubled is 2, doubled is 4, doubled is 8, doubled is 16. If we double 16, that's 32, and that's above 27. And so we doubled this 1, 2, 3, 1, 2, 3, 4, 5. So now we have to do that to 54 that many times. So we do 54, double that is 108, double that is 216, double that is 432, and double that is 864. So now we take these numbers and we take the ones that add up to equal 27. So we're going to take 16. 16 plus 8 is 24, so we're going to take this one. 24 plus 2 is 26. And then we need one more to equal 27. So meaning that, so all those numbers added together equal 27, so we're going to take their counterparts and add up those together to get the answer. So the counterpart of 1 is 54, counterpart of 2 is 108, the counterpart of 8 is 432, and the counterpart of 16 is 864. So now we're going to add all those together. I'm going to write this one out. So 54, 108, 432, and 864. So now those are all of our numbers. We're going to add those together for the final answer. So that's 18, carry the 1, 9, 10, 15, 12, 13, well, yeah, 12, 13, 14, 1,458. And just to double check, $1,458. So finally, for question 5, we were asked to divide the numbers we were asked to divide 4 by 7 using the Egyptian dividing method. So using the Egyptian dividing method, we use symbols and we just cut, like, we're dividing 4 loaves of bread for 7 people, and we essentially are just cutting the loaves in ways we can equally divide them. So the first way, and probably the easiest way, and the most common way probably that's going to be done, is just divide each loaf into 7 and give one person 1/7 of each loaf. So I labeled each number for a person. So person 1 got that piece, 2, 3, 4, 5, 6, 7. So each person is walking away with 1/7 of 4 loaves, and it's represented through here. So 1/7 plus 1/7 plus 1/7 plus 1/7 of a loaf. The second way I did it was, instead of cutting each loaf into 7s, I cut the loaves by fourths. So I cut the first loaf into fourths, cut the second loaf into fourths, cut the third loaf into fourths, and using half of the last loaf, I used that to cut it into 2/4 or a half. And so person 1, 2, 3, and 4 are getting a quarter of this loaf. 5, 6, and 7 are getting the quarters of this loaf, and person 1 is getting their second quarter right here. And then person 2, 3, 4, and 5 are all getting a quarter of that, and 6 and 7 are getting this half, but they're going to split it, and so each get a quarter. And so finally we have this final half piece of bread that we just cut in a 7th. And so it's a half cut in a 7th, so it's actually 1/14. So my final way to do it, I forgot to put the fractions in it, but that's okay, I'll do that now, is 1/4 plus 1/4 plus 1/14. So that's how each person is going away with a fourth, like 2/4 of the bread, or 1/2, and then 1/14 of a loaf.